Have you ever sat and wondered what causes the dramatic spectacle of thunder and lightning? The dance of light across the sky, followed by the deep, rumbling growl of thunder, is a natural phenomenon that has captivated and intrigued the human mind for centuries. From our ancestors who viewed these powerful displays as messages from the gods, to modern scientists who have dedicated their lives to studying atmospheric phenomena, thunder and lightning have remained a source of fascination and awe. This majestic spectacle is more than just a stunning light show. It's a testament to the sheer power and complexity of nature. Thunder and lightning are born in the belly of thunderclouds, where a fascinating tale of ice crystals, positive and negative charges unfolds. It's the dance of these elements that leads to the dramatic light and sound show we've come to know as a thunderstorm. To understand this, we need to venture high into the sky, inside a thundercloud. Imagine being inside a thundercloud, a place where the magic begins. Picture yourself in a bustling city of ice. In the penthouse high above, the air is chilly and it's filled with tiny ice crystals, light as a whisper. They are so small they could dance on the head of a pin. Down below, in the basement of our icy metropolis, it's a different story. The ice crystals here are larger, heavier. They are the heavyweights of this frozen world, and they rumble and tumble around like boulders. Now the real fun begins when these ice particles start to move, bumping and colliding with each other in the hurly-burly of the cloud. As they clash and crash, they do something quite extraordinary. They create a separation of charges. The lighter, smaller ice particles gain a positive charge and are swept up to the penthouse by the updrafts. Meanwhile, the heavier, larger ice particles, burdened with a negative charge, hang around in the basement, the lower part of the cloud. This movement and interaction of ice particles turn our thundercloud into a bustling city of electricity. With a positive charge at the top and a negative charge at the bottom, the entire cloud becomes electrified, humming with energy. This leads to the cloud becoming a giant battery, storing up an enormous amount of electrical energy. Watch out, because the real show is just about to begin. But how does this stored energy become the brilliant flash we know as lightning, you might wonder? Well, here's where the magic happens. Imagine the thundercloud as a colossal energy storage device brimming with electric charge. At the base of the cloud, there's a surplus of negatively charged particles. These particles are eager to find a way out, to find their positive counterparts. Now the Earth's surface below, being a good sport, obliges and becomes positively charged, induced by the cloud's negative charge. It's like two friends separated by a glass wall, desperate to meet. But here's the catch. There's a limit to how much they can bear being apart. When the difference between the negative charge in the cloud and the positive charge on the Earth's surface becomes too great, something incredible happens. A stream of negative charge, known as a leader, rushes towards the ground. This leader is like the advance party, paving the way for the main event. The leader doesn't always take a straight path. It zigzags, branches, seeks the path of least resistance. And when it's close enough to the ground, something on the Earth's surface, a tree, a building, or sometimes even an unlucky golf club, sends up a positive charge known as a streamer. And then the moment of connection arrives. When it connects with the positively charged ground, a powerful electric current surges upwards, creating the visible flash of lightning. Quite a spectacle, isn't it? Now that we've seen the lightning, where does the thunder come in? Well, the spectacle of thunder is directly linked to its flashy counterpart, lightning. As lightning zips through the sky, it superheats the surrounding air to extreme temperatures in a fraction of a second. We're talking about temperatures that can exceed 50,000 degrees Fahrenheit. That's hotter than the surface of the sun. This sudden and intense heating causes the air to expand rapidly, creating a shock wave that ripples through the atmosphere. As this shockwave propagates, it compresses and decompresses the air around it, causing the molecules to vibrate. It is this vibration that reaches our ears as the resounding boom we know as thunder. So the next time you hear that rumbling sound after a flash of lightning, remember that it's the result of a high-speed, high-temperature event happening miles above. And there you have it, the spectacular display of thunder and lightning, all due to the play of charges in a thundercloud.